Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2022, Paper 3, FoundationTier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. What is 1/4 as a percentage? Well, if I take 1/4 written as a fraction and I times top and bottom by something, so I end up with 100 on the bottom. So how many 4 goes into 100? Goes in 25 times, isn't it? So multiplying top and bottom through by 25, that gives me 25 over 100, which is the same thing as 25%, isn't it? So it's that one there. Question 2, circle the number that is a factor of 10. Okay, now I normally do my factors like this. I put 10 at the top and I write them down in factor pairs so I don't miss any. So start with 1 and 10 always go. Try 2, yep, 2 goes in, 2 times 5 is 10, 3 doesn't go, 4 doesn't go, and then I've kind of met myself coming down the other way then, so I know I've got all the factors there. So which one of those is on the list? It's 5, isn't it? Question 3, circle the value of the digit 9 in 0.094. Okay, well there's the 9 there, isn't it? So this digit here is the units, the next one along is the tenths. So the 9 digit is in the hundredth position, isn't it? So that 9 actually means 9 100ths. So 9 over 100. Oh, there's only one there. It's that one there. Question 4, simplify 4 times 2c, circle your answer. Well, all you have to do really here is just to multiply these two together, isn't it? So 4 times 2 is 8, so that is going to give me 8c. Okay, so 4 times 2 gave me that 8. It's this one. Question 5a, write a suitable unit for measuring each amount. One has been done for you, and we've got the distance from London to Manchester, and the offered unit is kilometres. Now we want to know the length of a pencil. What unit should we use for that? Well, you could happily measure the length of a pencil with a ruler, and your ruler is made up of 30 centimetres. So I think it would be quite okay to be measuring it in centimetres here. So I'm just going to write centimetres. And then the mass of a pound coin, well, the metric unit of measure for weight is grams, isn't it? And I think that would be fine for measuring a coin with. It would probably be about, I don't know, 100 grams, something like that. Okay, yeah, so grams. It certainly wouldn't be in kilograms, would it, the weight of a coin? So grams, I think, is the most sensible. Part B says times for the 3 parts of the journey are 20 minutes, 40 minutes, and 1 hour and 30 minutes. Work out the total time of the journey. Give your answer in hours. Okay. So now I need to add these 3 up. So I've got 0 hours and 20 minutes. I've got 0 hours and 40 minutes. And I've got 1 hour and 30 minutes. Okay. So with time, the best thing to do probably is to add up the minutes first. So 20, 40, and 30. That adds up to 60, 90 minutes. But 90 minutes is 1 hour and 30 minutes. So I'm going to kind of write the 30 in here and carry over the 1 whole hour into the next column along. And then I've got 1 hour, and 1 hour makes 2 hours. So altogether, that is 2 hours and 30 minutes. Give your answer in hours. Well, if I just have to give it in hours, 2 hours and 30 minutes is like 2 hours and half an hour. So I would say that 2 hours and 30 minutes is the same thing as 2.5 hours then. If it's just in hours, I would say that's 2.5 hours. So that's my final answer, 2.5. Question 6. Pens cost 20p each. Rulers cost 60p. Saj buys some pens and some rulers. He buys 8 rulers. The total cost is £10. How many pens does he buy? Okay. So I think what I'm going to do is I'm going to work out the cost of the 8 rulers first. I'm going to take it away from 10, and that's going to tell me the cost of the pens, and then I'm going to divide that by the cost of 1 pen to find the amount of pens. Okay, so that is my action plan. So I'm starting with the 8 rulers that cost 60p each. Okay, so if I've got 8 rulers costing 60p, if I multiply those together, cost of rulers equals 8 rulers times 60p. I'm going to write it in pence like that, 0.60. Right, so then multiplying that together on my calculator, 8 times 0.6, that comes out to be 4.8 or £4.80. Okay, so then I can then work out the cost of pens by taking my £10 that I spent altogether and subtracting the cost of the rulers. So 10 minus answer, that comes out to be £5.20. £5.20. Okay, so now I know that it's £5.20 for all of the pens. I can work out how many pens it is because I know the cost of a pen. So number of pens, and that's going to be the £5.20 spent on pens divided by the cost of 1 pen, which was 20p, wasn't it? So that's where that comes from. Okay, so then £5.20 divided by 0.2 divided by 0.2, that comes out to be 26. So that means they bought 26 pens. Question 7. The bar chart shows the number of medals won by a country at events in 2008 and 2012. So we've got the number of medals in 2008 and 2012 shown separately, and we've got a key up here. So the really dark bar is gold, the lighter one is silver, and the kind of middle one is bronze. So complete this statement about the medals won by the country in 2008. The number of silver medals equals something times the number of gold medals. Okay, so we need to know the number of silver medals and the number of gold medals won in 2008. So let's look that up from the key. So the gold medals are this darker bar here. So it's going to be that short little one on the left, which is 2, isn't it? So gold medals was 2. So in 2008, gold medals ones were 2, and silver, that's the middle bar, isn't it? And that's 6. So the number of silver medals is going to have to be 3 times the number of gold medals then, isn't it? 3 times 2 is 6. And then the second part says, show that the country won more medals in 2008 than in 2012. Okay, so for that one we need the total medals in both years then. So the total in 2008, that is going to be the 2 gold and the 6 silver that we already talked about, plus the third bar, which is 9, isn't it? It's got a height 9. So that's going to give me a total of 17 medals. And the total in 2012, well, they won more golds there. They got 5, didn't they? And then 1 more silvers as well. They got 8. but they only won 3 bronze medals in that year. So if I add those up, 5 plus 8 plus 3, that comes to 16. Okay, so you can see then in 2008 they won 1 more medal overall. So 2008 was greater than 2012 then in that case. And then finally, at the 2016 event, the country won an equal number of each type of medal. Here is the statement about the medals won in the country in 2016. The total number of medals cannot be 25. Give a reason why this statement is correct. Okay. Well, if they won an equal number of medals, then the total number of medals then must be divisible by 3, mustn't it? Okay, because you're going to have 3 times the same number. Now, 25 doesn't have 3 as a factor, and therefore it cannot be the total number of medals. So that's my reason. I'm going to say that 25 does not have 3 as a factor. So cannot be the total. Question 8. In this question, use 1 litre equals 1,000 millilitres. A mixture is made using white paint and red paint. The amount of white paint is equal to the amount of red paint divided by 7. 5.6 litres of red paint will make more than 6 litres of the mixture. How much more? Give your answers in millilitres. Right, okay, well the mixture is made up of the red paint and the white paint added together, isn't it? And we're told that we're using 5.6 litres of the red paint. So then how much white paint required have we got then? So the amount of white paint is going to be the amount of red paint divided by 7 then, isn't it? And we know that the amount of red paint is given as 5.6 litres. So that's 5.6, and let's write that in. 5.6, and then we're dividing that by 7. So what is 5.6 divided by 7? 5.6 divided by 7, that's 0.8. Okay, so that means we would have had 0.8 litres of white paint. Okay, so then the total for the mixture is going to be the 5.6 litres of red paint plus the 0.8 litres of white paint, giving you a total of 6.4 litres of paint. Okay, now that's not the question though, is it? It's not asking us how much it makes. It says how much more than 6 litres is that? How much more is going to be 6.4 minus 6 is going to be 0.4 litres, which in millilitres, that's 400 millilitres, isn't it? Because there are 1,000 millilitres in a litre, so there must be 400 millilitres in 0.4 litres. Okay, so that's my final answer. It's going to be 400 millilitres. Kind of a weirdly worded question there. You have to read it carefully, make sure you're answering the right thing. Question 9. Some students were asked about their daily exercise. 12 more students answered yes than answered no. Complete the frequency tree. Okay, so 12 more students answered yes than no. So that means 12 less students answered no then, isn't it, than 35. So the no one is going to be equal to 35 minus 12. So that's going to give me 23 people who said no. So I'm going to write that in the box here. So if 23 people said no and 35 people said yes, I now know the total number of people asked, because if I add those together, 35 plus 23, that comes to 58. So I can write 58 in that box there. Okay. Right, and then finally, what have we got here? So we've got one more box to fill. So we know that 27 students took at least 1 hour. So how many people took less than 1 hour? It's going to be the difference between 35 minus 27, isn't it? So the difference between those two numbers, 35 take away 27, That's going to be 8. So I'm going to need to have 8 people in there. Okay, so now so it's all complete now. All the little circles are done. Right, 9b, one of the students who answers yes is chosen at random. What is the probability that they exercise for at least 1 hour? So probability of at least 1 hour. So of the 35 students who answered yes, 1 is chosen at random. So the successful outcomes is the number of people who did exercise for at least 1 hour, which was 27, and we're picking from the 35 students who said yes, so that is the number on the bottom then. So it's 27 over 35. Question 10, shape X and Y are shown on the centimetre grid. 10a, circle the name of shape X. Well, shape X is made up of straight lines, and how many straight lines are there? There are 1, 2, 3, 4, 5, 6. So in my mind, that makes it a 6-sided shape. It's a hexagon. B, give a reason why shape Y is not a regular polygon. Well, it's not a regular polygon because for a regular polygon, all the sides need to be the same length. And you've got this one, which is of length 1. This one, which is not something between 1 and 2. It's like it's a root. And then this side is length 2. So yeah, they're all different. They're all different lengths. Okay, so regular polygons have all sides same length, whereas this shape has different length sides. Okay, and then finally complete these statements. The number of lines of symmetry in shape X is, right, how many lines of symmetry can we see? Well, I can see one kind of coming down the middle that way. That's the line of symmetry, isn't it? And there's one going across here. Is there one from corner to the diagonals? I don't think so. I think if you fold it over here, they wouldn't overlap. So that isn't one. Okay, so I'm going to say that there are 2 lines of symmetry for X. Now, and it's asking for the order of rotational symmetry for Y. Now, rotational symmetry is when we pick a center of rotation for the shape, and then we rotate it around that point 360 degrees all the way around. So give it a full turn, and then how many positions does it look the same? Now, I would say that that shape looks the same in 4 different positions as you rotate it around. Okay, so I'm going to say it has rotational symmetry of order 4. Question 11a, here is a number machine. I've got 58 as the input, 26 is added to it, and then it's divided by 21. Then we need to work out the output. Okay, well, what is 56? 58 plus 26 divided by 21. It's actually kind of implied brackets around there because we're adding the 21 first. Okay, so that's what we need to work out in our calculator. If I just wrote down 58 plus 26 divided by 21, the calculator is going to give me the wrong answer. I need to put brackets around it or subtotal after you've added the 26. So 58 plus 26 equals 81, and then 84, sorry, and then divide that by 21. That comes out to be 4. Okay, so that's my output there, 4. Part B says, here is a different number machine. This time we're inputting C. We're multiplying it by 3 and subtracting 5, and we're getting D. Work out the formula of D in terms of C. Okay, so D is what we're going to have at the beginning, because that's my output. And so C gets fed in, and we multiply it by 3. Now C times 3, we write as 3C, don't we? Okay, so I'm going to get 3C, and then after we get 3C, 5 is taken away, so it's going to be 3C minus 5. So D equals 3C minus 5. Question 12a, simplify fully 9x plus y minus 6x plus y. Okay, now this is a collecting like terms questions. So we've got a 9x term and a minus 6 term that are alike. and we have a plus y and a plus y that are alike. So add in the x's together first. 9x take away 6x, that is going to be 3x, isn't it? Kind of combining the yellow ones together. And then y plus y, well, that's just 2y, isn't it? So adding the green ones together, I'm going to get 3x plus 2y. Right, and here are two expressions, AA and a squared minus b. When a is 25, the expressions have the same value. Work out the value of b. Okay. Well, what is the value of 8a to start with? 8a is going to be 8 times 25 then. And 8 times 25 I know to be 200. And then, so if a squared minus b is equal to 200, then we know that 25 squared minus b is equal to 200. Now we want to rearrange this to make b the subject. So if I add b to both sides, okay, it will cancel off there, and I'll end up with 25 squared is equal to 200 plus b. And then if I take 200 away from both sides, okay, they'll cancel there, and then I'm left with b is equal to 25 squared minus 200. Okay, then typing that quickly into the calculator, 25 squared minus 200, that comes out to be 425. So that's my value of b then, 425. 12c says simplify 6w plus 10 over 2, circle your answer. Now, if you look at the numerator, I've got 6w and 10. Now, they have a common factor of 2. So I can take 2 out of 6w, and that leaves me with 3w. And I can take 2 out of 10, and that leaves me with 5. So that gives me 2 lots of 3w plus 5 on the top, and 2 on the bottom. And now I've got factors on the top that I can cancel with factors on the bottom. So those two are going to cancel each other out, and that just leaves me with 3w plus 5. So that's my answer then. Where's that one? It's that one, 3w plus 5. Question 13. In a bag, the number of green discs to the number of blue discs is in a ratio of 20 to 11. Tick one box for each statement about the discs in the bag. Is it true, false, or you cannot tell for these two statements? There are more green discs than blue discs. Is that true? Is that false? Can you not tell? Okay. Well, I know that the ratio of green disc to blue disc is 20 to 11. So I can definitely tell there are going to be more green discs, because for every 20 green discs, there are only 11 blue ones. Okay. So if I scaled up that ratio, I'm still going to always have more green discs. Can I say that in total there are 31 discs? Okay, now for that one it could be true. I could have 20 green ones and 11 blue ones, and that would give me 31. But this is a ratio, and ratios could be scaled up. I could have 40 green ones and 22 blue ones, which give me a total of 62. Okay, so for that one you can't tell. It could be that it's 31, but it could just as easily be a different number, some multiple of that ratio. Question 14a. How many students played more than 2 games? Now, more than 2 games means 3, 4 and 5 games here, doesn't it? So it's that bar, and that bar. So the total then would be the height of the third bar, which is 4, plus the height of the second bar, which is 1, plus the height of the third bar, which is 3. So 4 plus 1 plus 3, that is 8. And so that's the answer to that one. Work out the mean number of games played. Give your answer as a decimal. Right, if I made a quick table for games played and the frequency of how many times that was played, that's going to give me, so we've got 1 game, 2 games, 3 games, 4 games, 5 games. 1 game was played 7 times, 2 games was played 5 times, 3 games was played 4 times, 4 games was played once, and 5 games were played 3 times. So then the total number of games played by all of those people are those numbers then multiplied together. We're going to have to multiply those together to get the total games played. So 1 times 7 is 7. Those 5 students played 2 games. 5 times 2 is 10. That means they played a total of 10 games. 3 times 4 is 12. 4 times 1 is 4. 5 times 3 is 15. Okay, so what does that add up to? 7 plus 10 is 17, 27, 29, 33, 43, 48. So 48 games are played in total. There were 20 students altogether. So then the mean is going to be the 48 games played divided by the 20 students playing them. 48 divided by 20. 48 divided by 20. That comes out to be 2.4. So on average, students played 2.4 games. Okay. Question 15a. Work out the multiple of 60 that is closest to 400. Okay. Well, I know 5 60s is 300, so I'm going to just miss out the first few and start at 300. So 300, then 360, and then 420. Okay, so the difference between 360 and 400 is 40. The difference between 420 and 400 is 20. So that one is the closest, isn't it? So 420 is the closest multiple of 60 to 400. And then part B says work out the highest common factor, HCF, of 12 and 18. With small numbers like this, I think it's probably just as quick to do an exhaustive search. So I'm going to find all the factors of 12. So that's 1 and 12, 2 and 6, 3 and 4, not too many to find. And for 18, I'm going to do the same thing. 1 and 18, 2 and 9, 3 and 6, 4, no, 5, no, that's all of them then, isn't it? Okay, so which is the biggest number on both of those lists? Well, I can see a 1 in both, I can see a 2 in both, I can see a 3 in both, I can see a 6 in both. But the biggest one, obviously, is going to be that 6. Okay, so that makes the HCF of these two numbers equal to 6. Question 16. An empty container is a cylinder of radius 3.5 centimeters and height 40 centimeters. A tennis ball is a sphere of radius 3.5 centimeters. Will 6 of the tennis balls fit in the container? Tick a box, yes or no. So let's imagine, it's a bit like if you ever played tennis, you know that tennis ball comes in like tubes like this. Okay, so you get a tube of tennis balls. If you go to a sports shop, you'll see them there. Okay, and we know that this particular tube has a radius of 3.5. So it's 3.5 in that direction, and it's got a height of 40 in this direction. Okay, and inside that tube are a bunch of tennis balls. Can I fit 6 balls in here? Now the sphere, or the tennis ball, has got the radius of 3.5. Okay, so that means it fits in the width, doesn't it? So it has the same radius as the 3.5 cylinder. Assuming it fits in, it's going to be a snug fit, but let's assume it does. Okay, now what's the height of that tennis ball? If it's got a radius of 3.5, then it's going to reach 7 centimeters up, isn't it? Because it's 3.5 and 3.5 making 7. It's got kind of a diameter of 7 then, isn't it? So each tennis ball then is going to have a diameter of 7. So if you add another one on, it's going to be another 7. If you add another one on, it's going to be another 7. Another one on, it's another 7, isn't it? So how many 7s fit under 40? Well, 7, 14, 21, 28, 35, 42. Okay, so 42 would be the height of 6 balls, isn't it? Because 6 times 7 is 42. So that is too tall. It'll only fit 5 in. So too tall. So we can only fit 5 tennis balls in tube. So answer no. Questions 17a and b. These are just calculations. I'm just going to type them directly into the calculator and work them out. So calculate 2 to the power 7 times 5 squared I'm going to use 2 and the power key there and type in 7. Need to come out of the little square box thing, and then I can put the rest of it in. Times 5 squared. That comes out to be 3,200. Okay, and then the next question is asking for the fourth root of 20,736. Okay, now and then I need to have the root button. It's the one there above the X with the little, it's the one there above the power button. I'm going to have to press the shift key to get it. Can you see there's a little box in the top left corner? I've got to put the 4 in there, and I'm going to have to press the right arrow to come into the other box, and then I'm going to type in the 2736. And that comes out to be 12. Question 18, circle the pair of alternate angles. Well, alternate angles lie on opposite sides of the transversal, so it's going to have to be this pair here. Okay, yeah, so it's got to be that one, B and C. Question 19, juice and water are mixed together in a ratio of 2 to 7, and part A wants us to draw a straight line graph that shows the amount of juice and water to mix together. Your graph must show up to 10 litres of juice. Okay. Right, so we know that for every 2 litres of juice, we need 7 litres of water. So I'm going to plot that as a point. So for 2 litres of juice, we need 7 litres of water. Okay, so that's going straight on as a point there. Now, obviously, for 0 litres of juice, we need 0 litres of water. So that's also a point. And I'm going to go up in multiples of 2 because I can just scale up that ratio then. So if I double the ratio, then I know that 4 litres of juice is going to go with 14 litres of water. Okay. And 6 litres of juice is going to go with 3 lots of 7. It's going to go with 21 litres of water. And 8 then, 4 lots of 7 is 28, so 8 goes with 28. And 10, 5 lots of 7 is 35, so 10 goes with 35. Okay, so you should see it forms a nice straight line. Okay, I'm going to just draw that on with a ruler. Okay, so there's my line. And then part B says how much water is needed to mix with 5 litres of juice. So now I've got my line, I can use it to work out other values. So if I find 5 on my graph, I'm going to read up. And once I get to the graph, I'm going to change directions, go the other way. So that looks to me like it hits halfway between 15 and 20. So I'm going to say that's like 17.5. So that is 17.5 litres. You could work it out also from the ratio, you know, how many scaling up 2 to 5 using the... So the alternative way of doing it would be to use the unitary method. So go from 2 to 1 to 5. So divide by 7 by 2 and then times it by 5. You're going to get the same answer. 7 divided by 2 is 3.5. And then 3.5 times 5. Yeah, look, you get the same answer of 17.5. So, you know, it doesn't matter which one of those methods you use. It doesn't say use the graph or use ratios to work it out. So you've got a choice there. Either one would have been totally fine. Question 20. Adam and Bianca each throw the same biased coin. Here is some information about their throws. So Adam throws it 40 times and gets 14 heads. Bianca throws it 60 times and she gets 20 heads. Bianca says, my results give a better estimate of the probability of heads than Adam's result. Is she correct? Yes, she is. The reason for that is she's done it more often. Okay, the more times you repeat an experiment, the better your estimate of probability that you're going to get. So I'm going to say that it's true because she conducts more trials than Adam. 60 versus 40. Okay, yeah, so she does more trials, so her results are naturally going to be better. You get even better results still by adding them together. So if you add their results together, they've got 134. That would be the best estimate overall, because that's 100 is higher than 60 and 40. Yeah, so combining the results together, that would be the overall best, but they're not really interested in that in this question. So yeah, we've already answered it. Use trigonometry to work out the size of angle X. Okay, so this looks like a job for SOHCAHTOA, isn't it? Okay, we've got a right angled triangle. So we're going to be using either the sine, cosine or tangent, depending on which sides we've been given and which ones are missing. So let's have a look what we've got here then. So we've got angle X marked here, and we've been given the opposite side over here. So this is the op. And we've been given the adjacent side over here, haven't we? So this is the adjacent side. Okay, now this side over here, the hypotenuse, we're not really that interested in it because we don't know what it is and we don't want to find it. So any of our ratios that have got the hypotenuse in it are not the ones we want. So I don't want the sine because it's got a h in it. I don't want the cosine because it's got a h in it. It's going to be this one on the end, isn't it? It's TOA, tan, that we want. Okay, so I'm going to write down the trigonometric identity for tan. Tan theta equals op over adj. Okay, the tangent of the angle is equal to the opposite side divided by its adjacent side, and then we're going to sub in what we know. Okay, so it's not theta here, it's x, so tan x equals the opposite, which is 10, divided by the adjacent, which is 4. Okay, so this is one of the ones where I need to find the angle. So I'm going to be using the inverse tangent of my tan to the minus 1 of whatever that fraction is there, of 10 quarters. Okay, so I'm going to reach for the calculator. I'm going to type in shift and then the tan key, so I get tan to the minus 1. And then I'm going to type that fraction in, 10 over 4. And that's going to give me the answer, which is 68.2 to the nearest degree. So that's equal to 68.2 degrees. Before you move on, does it look reasonable? Does X look like a 70-degree angle? Yeah, it pretty much does. Okay, so I'm pretty happy with that. Laura works in a shop. The table shows the number of hours she works on 2 weekends. So we've got weekend 1, weekend 2, and we've got Saturday and Sunday. So it's a bit of a two-way table going on here. Work out the percentage increase in her total hours from weekend 1 to weekend 2. Right, so we want to work out the percentage increase in her total hours going from weekend 1 to weekend 2. Okay, so we need to work out what those are then, don't we? We need to work out how many hours she worked in weekend 1 and how many hours she worked in weekend 2, and then we're going to have to find the percentage change. Okay, so let's work out the total hours for weekend 1 and weekend 2 first. So we need a total. Okay, so I'm just going to add an extra column on the end of my table here. So for weekend 1, I worked 3 hours and 2 hours, so that, or Laura did, so that's 5 hours altogether. And then for weekend 2, it's 5.5 and 3.5. That adds up to 9 hours, isn't it? Okay. So right, now we need to do a percentage change question, isn't it? So I like to do these with a little triangle. Final, original, multiplier. So my method involves just identifying what these three things are from the question and then popping it into the formula and working through to the answer. Okay, so we want the percentage increase. Now the percentage increase is, well, it's the multiplier one, isn't it? The multiplier is the percentage written as a decimal. So we want to find that one. That's the one we don't know. Okay, and that's the one we want to find. Okay, now the final is the amount after the percentage increase has taken place. So here week 2 happens after week 1, so the final is going to be like the week 2 amount, which is 9 hours, isn't it? So that's 9 hours. Okay, and then the original was the original amount of hours, and that is the amount for week 1, which is 5 then, isn't it? So that's going to be 5 hours. Okay, and the 9 was the green one, wasn't it? Okay, so now I know the final and the original, I can then easily find the multiplier. Put my thumb on the one I want to find, cover it up, And then that tells me that the multiplier is equal to the final divided by the original. So multiplier equals final divided by original. And that is equal to, what's that? That's final 9 divided by original 5. So if I type that into the calculator, 9 divided by 5, that comes out to be 1.8. Now remember, that's as a decimal, isn't it? So if I want that as a percentage, that is going to be 180% as a percentage. Okay? But that doesn't tell me the percentage increase. Now, whenever you've got a percentage increase, you always start with 100%. So if I started with 100% and I've now got 180%, that means that the percentage increased by 80%, which took my 100% up to 180%. Okay, and that's my final answer. So the number of hours increased by 80% from week 1 to week 2. Here is a sketch of a curve y equals x squared minus 4x minus 5. And we've got the graph. It's showing me the roots. I've got the y-intercept and I've got a point T, which I'm guessing is the turning point or the lowest point on the curve. Now it says write down the two roots of x squared minus 4x minus 5 equals 0. Now the roots are where it passes through the x-axis, and I can see there then that the roots there are at -1 and at 5. Okay, so the roots are -1 and 5. Part B says work out the coordinates of t, the turning point of the curve. Okay, now to find the turning point we need to complete the square, don't we? So I'm starting with y equals x squared minus 4x minus 5, and I'm going to rewrite it in the form of x plus or minus something all squared plus or minus something on the end. Okay, now that number that goes here is always half of this one here, so we take that one and we halve it, and that's what goes inside the bracket. So I'm going to get x minus 2 all squared. Okay, now that minus 5 that's there is still going to be on the end because I haven't dealt with that yet, but x minus 2 all squared is not a perfect replacement of x squared minus 4x. It's actually x squared minus 4x plus 4, so I need to take off 4 from that bracket to actually make it equal to the thing that's above. Okay, because at the moment this thing and this thing are not quite equal. Okay, it's minus 4 more the second thing than it is than the first thing, so I have to take it off so it balances back out again. Okay, so once I got that, I can just tidy it up. X minus 2 all squared minus 4 minus 5, that makes minus 9. Okay, so that's my equation in completed square form. So the lowest point, or the turning point, is going to be where that amount is the lowest value it can be, and that is going to be when the bracket part is equal to 0, and that occurs when x is equal to 2. So if you make x equals 2, then you get 2 minus 2 is equal to 0, and 0 squared is the lowest value that you can have, because when you square something you always get a positive number, so the very least it can be is 0, and that occurs when x is 2. And when x is 2, then the first bracket will disappear and you'll end up with y is equal to minus 9. Okay, so an easy way of thinking about it is the x value is just a negative version of that number up there, and the y value is the one on the end. Okay, that's all you get. So it's going to be at 2 minus 9 basically. So what is the coordinates of t? T has got the coordinates 2, negative 9. A is an arithmetic progression. Here are the first 4 terms. So it's going 13, 16, 19, 22. G is a geometric progression. Here are the first 4 terms. It's going 2, 4, 8, 16. The nth term of A is equal to the 8th term of G. Work out the value of n. Okay, so what I'm going to do here is I'm going to find the nth term of each expression, and so then I can compare those a bit later on and hopefully solve for n. Okay, so let's do that then. So the nth term of the first sequence, can you see it's going up in plus 3s, isn't it? Okay, plus 3, plus 3, plus 3. So the nth term is going to have something to do with, I suppose we should call it This is a, isn't it? So let's call it an. An, the nth term of a, is going to be equal to 3n plus what? Well, 3n would be 3, 6, 9, 12, and I've got 13, 16, 19, 22, which is, they're all 10 more than those values, aren't they? So the nth term of a is going to be an equals 3n plus 10. Okay. Now, the nth term of a geometric progression is equal to the first term, which is a, times the common ratio. What's the common ratio here? 4 is twice as big as 2. 8 is twice as big as 4. So r, the common ratio, is 2. So the general form of a geometric progression, nth term, is going to be a times r to the power of n minus 1. It's just a thing that you need to learn. Then subbing in our two values for a and r. A is 2, r is 2. So I get 2 times 2n to the minus 1, which you could simplify as, because I've got a 2 times 2 n to the minus 1, and that's the same thing as 2 to the power of n. Okay, it doesn't really matter because we're gonna sub that out in a minute anyway. Okay, so then the next part says the nth term of a is equal to the 8th term of g. Okay, so let's just find the 8th term of g. G8. That's going to be 2 to the power of 8, or it's 2 times 2 to the power of 7, which is 2 to the power of 8. If I just stack with the original thing, and that thing there that is confusing you. But anyway, that's 2 to the power of 8. What's that? 2 to the power of 8 calculator. I could do it on my hands, but hey ho, got a calculator. 2 to the power of 8, that's 256. Okay, so then I know that my nth term of a, 3n plus 10, is equal to my 8th term of g, which is 256. So now I can solve for n, can't I? Taking 10 away from both sides, that's going to give me 3n is equal to 246, and then dividing both sides by 3 then. So 246 divided by 3, that comes out to be 82. So it's the 82nd term of a, which is equal to the 8th term of g. So geometric progressions get big very quickly. So I had to go quite a long way along the arithmetic one to get that high as the 8th term of the geo. Okay, so n is 82, job done. Question 25, the L shape is made from rectangles. We're told that the area is 44, work out the perimeter. Okay, now to work out the perimeter, we're going to have to know the lengths of each of these lines, aren't we? And at the moment, we've got this one missing, we don't know, and we don't know this one. And if I don't know those two, then I can't really infer them. You know, often with these problems, you have to kind of take one away from the other and work it out. But with both of those missing, there's no way for me to work out those two lengths from the diagram that's already there. But what I can do is I can use this area and kind of work backwards to find the lengths. Okay, so I'm going to do that by dividing this rectangle up into other rectangles. I'm going to divide it like that. So this one here, I'm going to call area 1, and this one is called area 2. Okay, so, and I'm going to call this missing length here x. And I'm going to say then that the area of my shape is going to be area 1 plus area 2. Now, area 1 is a 2 by 4 rectangle. So that's got an area of 2 times 4. Now, area 2 is a 3 times x rectangle, but I don't know x yet. And I do know that the overall area is equal to 44. So what I've done here is I've formed an equation in x. I've got 44 is equal to, just multiplying that out, is equal to 8 plus 3x. So then taking 8 away from both sides, I'm going to get, they're going to cancel. It's going to leave me with 3x is equal to 36, and then dividing both sides by 3. So divide by 3, that's going to give me 12 is equal to x. Okay, so now I know that this is 12, then this side on the other side must be the 12 take away that 2 up there, so that's going to be 10. Okay, so now I do know all the sides. Okay, so now I can go ahead and work out the perimeter. So then the perimeter of this shape is just going to be all the different sides added together. So starting in one corner and working my way around the shape, it's going to be 2 plus 4 plus 10 plus 3 plus 12 plus 7. So what does that all add up to then? So 2 plus 4 plus 10 plus 3 plus 12 plus 7. That comes to 38. So this shape has a perimeter of 38. Question 26, work out 3 lots of 1, 6 plus 2, 5. Okay, so these are column vectors. We use them in things like translations, amongst other things. And this number on the front here is what we call a scalar. When you multiply a column vector by a scalar like this, then that number gets multiplied by the 3 and that number gets multiplied by the 3. So 3 lots of 1, 6, that is going to be equal to 3 times 1, which is 3, and 3 times 6, which is 18. So that's going to give me 318. Now if we're going to add on 2, 5 onto that, then I'm going to add this number with this number, and I'm going to add this number with this number, and that's how these column vectors work. Okay, so 3 plus 2 gives me 5, and 18 plus 5 gives me 23. So that is my answer, 523. Information about 2 fridge freezers, A and B, is shown. Okay, so we've got fridge A, which is a fridge freezer, total capacity of 330 litres, and the fridge capacity to the freezer capacity is 3:2. And we've got fridge B. It's got a fridge capacity of 294, so slightly less. The fridge capacity to the freezer capacity is 7:3. Okay, you can see looks like the freezer capacity is slightly smaller compared to its rival over there. Grace buys one of these fridge freezers. She buys one with the greater freezer capacity. Which one does she buy? You must show your working. Okay, so is this one, which is deceptively not drawn to scale, have a bigger freezer capacity than... Oh no, it's the other way around. Oh yeah. So which one of these beasts here is going to have the highest freezing capacity? Let's work it out. Okay, it's basically a division divided by a ratio question, isn't it? Because I've got, for each of them, I know how much they each contain, and for each of them I've been given a ratio. So if I can divide those amounts by those ratios, I should get the fridge capacity and the freezer capacity, shouldn't I? Okay, now dividing by a ratio is pretty easy. Just take the original ratio and add the 2 bits together. So 3 plus 2, that's equal to 5, isn't it? 3 plus 2 is 5. Okay, so that means there are 3 shares and 2 shares, being 5 shares altogether. If you divide 330 by the number of shares, you should find the value of each share then. So 330 divided by 5, that tells me that the value of each share is 66, in this case litres. So then if I then take that original ratio 3:2 and I scale it up by a factor of 66, it should give me the capacity of each part of the fridge. Okay, so the fridgey part is going to be 3 times 66. 3 times 66, that is 198. 198. And the freezery bit is going to be 2 times 66, which comes out to be 132. Okay, do the same thing for the second one. For fridge B, notice that fridge is in bold here. So this one is set out slightly differently. In the first part we were given the total amount, so we needed to divide by ratio. But here we've been given the capacity of the fridge part. So if I write the ratio of the fridge part to the freezer part as 7:3, we now know that the fridge capacity is 294. Okay, so what we need to know is how many times 7 goes into 294. So if I type into the calculator 294 divided by 7, I get the answer 42. So I'm scaling up this ratio by a factor of 42. So if I'm doing that to the left-hand side, I need to do it with the freezer capacity side as well, don't I? So if I times that by 42 as well, then 3 times 42, that's 126, isn't it? 126. Okay, so which one do we want? We want the one with the greater freezer capacity. Which one has got the biggest freezer capacity? Well, this one has got a freezer capacity of 132. This one has a freezer capacity of 126. So no competition. Fridge A wins. So which one do we want? Fridge A has biggest freezer capacity. Tom and Adil are the two runners in a 200-meter race. Tom completes the race in 24 seconds. Adil completes the race at an average speed of 28.8 kilometers per hour. Who wins the race? You must show your working. Okay, well, I guess the person who wins the race is the person who runs it in the shortest amount of time. Now, Tom completes the race in 24 seconds, and we know it's a 200-meter race. Adil completes the race at an average speed of 28.8 kilometers per hour, so we should be able to work out the time it takes because we know the distance that he ran. It was a 200-meter race, and we know the speed he ran it at. Okay, so the only thing we don't know is time there, isn't it? So using the DST triangle, distance, speed, time. If you hadn't noticed, they're alphabetical from top to bottom, so it should be easy for you to remember which way around it goes. And then see if we can identify what D is, what S is, what T is. Well, the distance is the distance traveled, isn't it? Which in this case is 200 meters. It's the value that we had up there. The speed is 28.8 kilometers per hour, which is we got from there. And so the only thing that we don't know then is time, and that is the thing we're trying to find, isn't it? How long it took him to run the race. So covering up T, that tells me that time is distance divided by speed. So time equals distance divided by speed. Now the distance was 200. A slight issue here in that we got different units, haven't we? Okay, so in order to sub in meters and kilometers, probably best idea to convert that into kilometers first before we go any further. So I'm going to say, well, 200 meters, that's the same thing as how many kilometers then? So there is 1,000 meters in a kilometer. So 200 meters is going to be 0.2 of a kilometer then, isn't it? Okay, so I'm going to rewrite that one as 0.2. So then my units all match. Okay, so I've got 0.2 kilometers. So 0.2 divided by 28.8. What's that then? That's a very short time in hours. 0.2 divided by 28.8. It comes out to be 144th or 6.94. Looks like it's reoccurring there. Might just write that as 1 over 144 for now. So that's in hours, isn't it? Okay, I don't want it in hours, I want it in seconds so I can compare it with Tom's time. So to convert that into seconds, I'm going to have to multiply by 60. That will tell me the number of minutes, and times another 60 to give me the number of seconds. So taking my answer and multiplying it by 60 and then multiplying it by another 60, that is going to give me 25 seconds. Okay, so now I can see then I've got 25 seconds for, this was Adil, wasn't it? We're doing Adil's race at the moment. We know that Adil then is 25, and we know that Tom completed it in 24 seconds then. So who's faster? It's Tom by a second, isn't it? So Tom fastest. And the mass of a baby is 3.6 kilograms to 1 decimal place. What is the error interval for the mass in kilograms? Tick one box. Okay, so when I'm doing these, I like to draw a number line and mark on the number they've given me, which is 3.6. Okay, so that's the number they gave me, 3.6 there in the middle. Right, and then it says that this number is only correct to one decimal place. Now, the first decimal place is the tenths column there. So 1/10 more than 3.6 would be 3.7. So that would be the next number that you could possibly round up to. And the one below it would be 3.5 on that scale. So if I'm rounding to the nearest decimal place, I'd be rounding between these numbers. If it was closer to 3.6, it'd be 3.6. If it was closer to 3.7, it'd be 3.7. So which numbers round to 3.6 then? They're going to be the ones that are halfway between those or closer. That's the zone that rounds to 3.6, isn't it? Okay, now the start of that zone is halfway between 3.5 and 3.6, which is 3.55. So that's my lower bound. Okay, and then my upper bound is going to be halfway between 3.6 and 3.7, which is 3.65. Okay, so I need the boundary that is, so for my mass, it's going to be greater than or equal to 3.55, but strictly less than 3.65, because really 3.65 rounds up to 3.7, doesn't it? So it's still the boundary, but it rounds up. Okay, so which one is that then? So it's got to have 3.55 at one end. Okay, so it's either this one or this one, but there's only one that's got the less than symbol on the other side, which is that one there. So it's going to have to be this one. Okay. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.